Hello everyone, this is an introduction of big data and Hadoop. So coming to the big data, uh, we all know that what is a data? A data is a collection of information, and this data can be categorized in terms of volume, variety and velocity. Now coming to the volume, so this volume can be said as in terms of size like bytes, kilobytes, megabytes, gigabytes, petabytes, terabytes, and that's an extension up to yottabytes. And the research is going on. So, is there anything which is beyond yottabytes? That is said to be the volume. And coming to the velocity, suppose I would like to write the data from one location or one storage to another storage. There will be a hardware specification and software specification as the writing speed will be 25 MB per second or 30 MB per second. This cannot be increased. If that can be increased, then the hard disk get fail because of the writing, and the hard drive or hard disk, whatever we call, is said to be crash. And coming to the variety, so the data can be said as variety in terms of structure, unstructured and semi-structured data. Here the structured data is a data which has a schema. The best example for the schema is banking system or the tables or the RDBMS kind of thing. The simplest we can say as tables, the databases like Oracle, MySQL and SQL. Now these are the things like volume, velocity and variety. But there are the problems in this with respect to volume, velocity and variety. What are the problems? Coming to the volume, actually the data or whatever we are going to discuss about the big data, like the main purpose of the data is, or for big data is, to store and process the data. Till now, the data will be like gigabytes, petabytes, and they can be stored in terms of like up to gigabytes only, so maximum level of terabytes. So we can't go beyond. Suppose if I would like to store the data or I would like to process the data which generates a 10 petabytes per day, then how can it be? There is no such criteria with respect to the data. And coming to the velocity that I discussed, like there will be some system crash if I increase the hardware specification or software specification up to 30 MB per second or 40 MB per second, which is the limited in the with respect to the hardware and software specifications. And coming to the variety of the data which is in the form of structure only we are using so far. And so according to the survey and records, the data which is in the form of, out of 100%, 80% data is unstructured data and 20% data is a structured data, which in real time the only structured data is we are using. We have a laptop, we have so many files like Word, Excel, movie files or PDFs, whatever that will be in the form of file. The file is said to be a unstructured data because it has no schema. And semi-structured data, a semi-structured data is a combination of unstructured data and structured data. The best example for semi-structured data is social networking. Facebook generates nearly 10 terabytes of data every day. If an aeroplane passes 10 minutes or travel 10 minutes in air, it generates approximately of 10 terabytes. In that case, then aeroplane or airport authority, how much they will collect the data per day. That's amazing, right? So these are the problems, and the problem they would like to overcome. Then only by taking the combination of these three V's like volume, velocity and variety, big data came into the picture. Big data is like the data which we can deal with a large amount or huge amount of data to store and process the data. So according to Wikipedia, like in information technology, the big data is a collection of data that will be the so large, and if that is the complex, it becomes too difficult to process using on-hand database management tools. Like here in the present slide, that what you are looking like, the data which is difficult or which is to process the data by using the existing current traditional systems or databases. So to overcome this, we came the big data, and Hadoop is the primary thing which makes a cluster kind of thing there, and there will be several machines will be there, and for Hadoop there will be distributed file system which can store, the simple example that can be like, which can store 10 terabytes of data in 10 minutes including the process. And even if the hardware is good, if we provide the hardware more high availability, then the time will be decreased. How beauty. That is the big data, and from the big data we are going to the Hadoop. So somebody may or anyone can get doubt, so how it exists. In 1990s, Google, for their own distributed file system, they researched and they developed and they implemented, and later they released as a white paper that is called Google file system. And see, this big data and Hadoop, this is the open source. By taking the reference of this Google white paper, they implemented HDFS, and in 2008 it became as Apache TLP, and later that can be transferred into HDFS. Coming to MapReduce, actually, so MapReduce is the topic which we will use for the processing of the data after storing of the data. HDFS is the topic which will be used to store the data, and MapReduce is the to process the data which is stored in the HDFS. And that also implemented by the Google, and they released the white paper. This open source, the contributors from the Apache, they took the white paper and they referred the white paper and they implemented as the MapReduce in 2008, and the 2008 it became Apache TLP. So we have a system to store the data and to process the data. Then what about a database kind of thing like RDBMS? Similarly, Google also implemented its own database system or schema. It's said to be a big table. In 2006, it released as a paper, and in 2010, that we converted as a HBase and Cassandra. So for computing graph kind of thing, with respect to Google released a large scale graph computing at Google, and here like Hama and Giraffe. You know, Dremel. Can you complete like Dremel? Here is the Apache drill. Spanner. It will be something. It's going to be implemented soon as possible. And for a Hive, so Facebook used Hive. Okay, and that will be now it's an open source. And coming to the pig is one of the topic in in Hadoop, and that be implemented by Yahoo and contributed as an open source. There will be a 4 to 5 years Google is releasing and that will be implementing. Coming to real-time different big data scenarios. So is Hadoop good for it? What are the alternatives? Coming to real-time processing, no. And iterative processing, no. Ad hoc iterative querying, no. Because the alternatives like head streaming, Twitter Storm is there for real-time processing. For iterative processing, we have the Hama, Apache, Giraffe, Jung. This is with respect to some other tools. And ad hoc interactive querying, no. But For batch processing, the Hadoop or big data is perfect, because we can take the data, we can collect data as a whole, and we can store the data, and we can process data. So it's a perfect for the batch processing. In near future, it's a soon, I think, because the current existing projects of Hadoop, they're going to implement, and the research is going on with respect to transactions or with respect to anything which is already best for the batch processing is fine, but other things like transaction management or whatever, these Hadoop project is going to implement it very soon. And if that happens, the world will change. All the existing systems can convert or can implement this to make a complex project as a simple project to do. Where is this going? Now Hadoop acting like a kernel, because see, these all of the systems like Cloudera, actually the Hadoop is a basic thing, is a distributed file system to store the data and to process the data. We have so many distributors. For example, Java is open source, but it is maintaining by the Oracle. Similar kind, Hadoop is open source, and this can be taken up by the open source code is taken up by the different distributors like Cloudera, Hortonworks, even Microsoft, Mapper, IBM, anyone, they are taking upon that, and they implemented their own project. Like for example, if you take the Cloudera is considered as CDH, Cloudera Distributor Hadoop. And Hortonworks, they are implementing their own by taking this open source like a Hadoop distributed platform. And we have the ecosystem. In this ecosystem, we have Hive, HBase for Hive is for the querying. Suppose previously I discussed it, like we have the in previous slides I discussed it like HDFS to store the data, MapReduce to process data. For this MapReduce, we can do in the form of by using the Java code or Python code. If you don't know Java and Python, then you can go with the C++ definitely, or we can stream the data. Suppose you don't, it doesn't know, we are not from the background of Java or any language development path, then you can work with the Hadoop with respect to Hive. Hive is a query language, and it will be as easy as like SQL language or query language that we will use for the Oracle, MySQL or SQL databases. And coming to HBase, here the HBase is a thing like we need a database structure, and this HBase is a part of NoSQL schema, which is vice versa of RDBMS. RDBMS like Oracle, all the databases is there, and this is a traditional database which is the form of row oriented, where NoSQL is a thing which has column oriented database, graph oriented and document oriented database. So HBase is the database to store the data that comes into the Hadoop. And Flume, suppose a client used to generate the logs, and that logs we need to push into the Hadoop. That can be done by using Flume. Or the simple example is like I have a Twitter account, and from my Twitter account I would like to push the data into Hadoop. So Flume is the best thing for the Hadoop to push the data into Hadoop. And Scoop, suppose I would like to import the data from RDBMS to Hadoop, then Scoop is a connector which can use to connect the data, just like a JDBC connection, if the people are aware of JDBC. And this is the pig, and this is a Ambari, and this is a Hama camel, and this is a pig. So you know about the pig. like see if you know the C++, some kind of things script in terms of scripting language we will use a pig. And here coming to LinkedIn, Yahoo, eBay, Facebook, there are the contributors to make the Hadoop as an open source. And this Cloudera, Hortonworks, Microsoft, DataStack, Mapper, and these are the distributors they are distributing, and they used to make the support everything. And the basic thing is Hadoop HDF is a prerequisite, like it it should be, the service should be in on to work with all these respective ecosystems like Hama, Flume, or analytics for the analytic process to query easily and to get the analytical graphical view. And Mahout is a machine learning HBase. So this will be very interesting, quite interesting. Like see, um, a big data can change the world towards what happens to data once it is stored. If you are not taking advantage of big data, then you don't have a big data, you have just a pile of data. So here is some descriptive, what happened, why did it happen, when did it happen. Okay. And see this evaluation of big data use case, like log, we can use log parsing, search index. Recent ecosystems have been existed like search, so you can search your files like Google, you can search the structured data, or you can search the unstructured data, whatever you need, if you are that been stored in the Hadoop. The flexibility and facility is not given by the any existing systems apart from the big data. That's why all the people are looking into the big data. The few use cases like the old bank, they're using it, and neural networks, and in the medical stream, and in the everything, like to for the fraud detection. Suppose in US you have a theater and you have a coffee shop beside the theater. So a client came from that coffee shop, asked like how to increase the sales by using this big data scenario. So anyone can do that. They did like this idea, like the people who are going to the theater after ending of the show, when they're returning back, they're getting the message, besides this they have a coffee shop, please relax for some time. Or before going to the movie, they're getting the message. So the people, they thought, okay, just will go for the relaxation, and they will go for the relaxation to the coffee shop, in such that they can increase the sales for the coffee shop. And the best example for this big data use case is politics. Now in US, the US campaign, elections campaign are there. So the political people or the politicians, they will use this big data analysis, analytics, to make the survey and to get the how pros and cons of their election campaign. So this is about the big data. And coming to the Hadoop, Hadoop is like, I have a course structure of Hadoop, and this is a big data. It like 30 to 35 hours of training with respect to certified industry expert, and this is a Hadoop certified by Cloudera. We'll have the Hadoop distributed file system and big data. What about big data and what is Hadoop? And it is a multi-cluster. So what is a multi-cluster and how can we go with multi-cluster? And this is a map reduce. How we can go with the map reduce? How can the process data, and what is the job and why we are going to the job? And Hive. How can we install Hive? How can we work with Hive? This is a query language. And Pig like Lightning scripting shell queries. And HBase, I said for the HBase is for the installation, and how we can work with the HBase. Scoop is a connector and other ecosystems. And at end of the course, there will be one project which will be used for the real-time use cases, which doesn't find in the Google, because Twitter analysis or log analysis. This is a common project which are showing in all the projects. But apart from that, I would like to give a real-time project which will be useful for the growth career. Um, thank you very much.